Today we're doing problem 73 of the blind 75 set matrix zeros. So let's just get into it. Given an m by n integer matrix called matrix, if an element is 0, set its entire row and column to zeros. And something important is that we have to do this in place. So what does that mean? It means that we can't create any kind of auxiliary matrix on the side to kind of keep track of what we have to replace, and really we have to just deal with the given matrix. So we can't create any extra data structures to solve this problem. So let's look at the example, right? So given all these ones and a 0 in the middle, we would replace the row that the 0 is on with all zeros, and so do the same with the columns. Pretty straightforward, and it gets a little bit more complex with the second example and our approach, which we'll talk about in a second. In the second example, we have a 0 in both of the top two corners, so you can see how it replaces the same row that they're on with zeros, and similarly with the columns. So let's talk about an approach for this, and I think a straightforward one that a lot of people would jump to, including myself, which would be a mistake, is to loop through the matrix, and every time you see a 0, you just go ahead and replace the rows and the column that it's on with zeros. Simple enough, it's straightforward. Well, let's talk about why that wouldn't work. So let's go over to this drawing. This example here is pretty much the same as this one we just looked at, but I just used 3 rows and 3 columns to make it simpler. So let's think about if we were going to replace the rows and the columns with zeros every time we saw a 0, how this would work and why that's a problem. Let's say we're looping through and we start at the top left corner, we see a 0, and great, we've identified a 0. Let's go ahead and replace everything in this row with a 0 and everything in the same column with a 0, right? So if we were going to go ahead and do that, this would become a 0, this would become a 0, it's already a 0, so it doesn't matter. This would become a 0, and this would become a 0. And for the sake of consistency, I'm also going to just draw 0 over itself. We would then move on to this cell here, and we would also see that, hey, this is also a 0. So we'd replace the row with zeros, but we'd also replace the column with zeros, and that's incorrect, right? You could see how now replacing everything, by everything I mean the row and the column with zeros, would not be a correct move, because we are not remembering the original placement of the zeros. And what do I mean by that? It means that the problem that we're really trying to solve here is, how do you remember in place the original position of the zeros? So to solve that, what we can do is something like this. Knowing that we have to deal with our data in place, we can't create anything else, it leads us into the next question of how can we manipulate the given matrix such that we're able to remember where these zeros are, right? And to do that, what I'm going to do is I'm going to mark them. And when I find a 0, the approach is I'll loop through the matrix. When I find a 0, I'll replace it with an X. And what does that do? That actually just tells me the positions at which I need to start replacing. So one loop will go through the matrix and replace everything with an X, that is a 0. And I'll loop through it again. And what I'll do is, now on this loop, if I see an X, I'll first replace itself with a 0. And I'll go down the row, and I'll also replace everything that is not an X with a 0. And I'll do the same thing with the column. And I'll explain why we don't replace this with a 0 in a second. So now we've replaced the column with zeros and everything in the row with a 0 as long as it's not an x. So why do we leave the x alone? We leave the x alone because similarly to how we did it with this cell in the beginning, the first thing we do is actually just change the x to a 0. We want to retain our x's until we deal with that individual x, because we'll flip it to a 0 later on, and it just kind of helps with keeping this clean approach to actually updating the cell itself. If we move on, right, looping through this matrix, we'll go to this position here. It's not an x. Eventually we'll hit this position here. It is an x, and we'll replace this with a 0 first. And then we'll go through its row. Well, everything's already a 0. And then we'll go through its column. And here we can see that by marking the cell that originally was a 0 with something else, like an x, or really just some kind of string or whatever that's not a 0, that will allow you to remember, in a way, where the original positions were that you want to replace. So I think this will make a lot more sense once we start coding. So let's just get into it, right? And just like any other problem, the first thing I'm going to do is check if it's null. And we'll just return here if we're dealing with something that we can't really perform any operations on. So the first thing I'll do is keep track of some of the dimensions. And like I said before, what's the first thing that we're going to do? We're going to mark the positions of zeros with an x. So we're going to loop through. We're going to mark the positions of zeros with an x here. And what's the next thing that we're going to do? Well, now we're going to go find those x's. We're going to loop again. We're going to find those x's. And every time we find an x, we're going to update, right? I'll write the comment later. It'll make a little bit more sense. But here, if matrix.i j, if the cell value is equivalent to an x, what should we do? Well, let's replace the row with zeros. For x and columns. If matrix so now we're going to replace the row with zeros, right? And I'm using x here to loop through the columns, because columns is going to be, if we're going to replace the row values, then we want to move across the columns, right? So that's why we're using columns here. And this is going to be this is equivalent, actually, really, if it's not equivalent to an x, then we're just going to set matrix I x equal to 0. So to make this clear, I'm going to write replace row with zeros as long as cell value is not we'll zoom out, an X. And now we're gonna actually do the same thing, but with the rows. Sorry, the columns, right? Replace columns. So let's use Y instead. And this should be rows. And this should be Y and J, right? I actually forgot here, the first thing we should do is replace X with a 0, right? Like I said before, when we come across an X, the first thing we'll do is actually update that value. So on 21, if matrix at this cell, ij, is equivalent to an X, let's set it to a 0 first. And then we'll go ahead and loop through the row and the column that it exists on, and replace those values with zeros as long as they're not X's. So replacing the rows, matrix at I, okay, replacing the columns. Yeah, this looks good to me. Okay, so now that we're done with this, we've done everything in place, we should just be able to return the matrix. Right? Let's run this. And what is above? Int object is not subscriptable. This was missing the J here. Great. So let's talk about the runtime and the memory utilization. Let me zoom in a bit here. Cool. So runtime wise, we're doing one loop through our matrix. If there's n values in our matrix, then it's just O of n. And yes, it's a m by n matrix, so I'm just going to treat n as the total number of cells in our matrix. So this would be an O of n operation. We're going to loop through it again. That's also O of n. So our runtime is actually just O of n. Memory, we're not using any memory. That's kind of what makes this a good problem, is we've manipulated the data that we were passed in, so our input. Yeah, hope that helps.